Applications of radical functions. The voltage of a light bulb, V in volts, is related to the power, P in watts, of the bulb, and the resistance of the light bulb, R, which is measured in ohms. The equation relating these three variables is V is equal to the square root of PR. If you've taken Physics 11, you may or may not have studied electrical circuits. Some teachers do it in that course, some teachers do it in Physics 12, but you might have actually seen this formula or something like it in the past. But if you haven't, that's okay. We're told what the formula is, and as far as mathematicians are concerned, that's all they need to know. So the example would be calculate the power used by a light bulb, which is plugged into a standard 120 volt household electrical circuit and has a resistance of 144 ohms. So we're told the volts of the whole household electric circuit, which means that we've been told V in the formula. We've also been told the resistance, which is 144 ohms, which means we've been told R in the formula. So to write what we have so far, V is equal to the square root of PR is the equation we begin with. And we've been given that V is actually equal to 120. And we've also been given that R, so we don't know what P is, but we know that R is 144. So now we can go ahead and solve this radical equation. So to do that, I will start by squaring each side. And I'll have 120 squared, which I definitely need to do in my calculator. And when I do that, I get 14,400 is equal to P times 144. And then I divide each side by 144 and see what I get for my resulting power. So I get P is equal to 100, and the units for P are watts. I know that again from up here in the description of the equation. Make sure to always include your units on application problems. The speed of a tsunami wave, S in meters per second, is related to the depth of the ocean, D in meters, at the point of the wave. So S is equal to 9.8 times D. So what that means is that if you have the bottom of the ocean changing in depth and a wave above it, so here's a let's take a tsunami wave. The depth underneath that the wave is underneath the ocean, or I should say, the depth of the ocean underneath the wave affects the speed. So it travels faster in deep water, and then as the depth decreases, the speed will decrease as it gets closer and closer to shore. So let's determine how many times faster does a tsunami wave travel through the Juan de Fuca Strait, which is roughly 200 meters deep, compared to the speed of the wave in the open ocean, which is an average depth of about 3.7 kilometers. So we'll have to be very careful with our units in this question, because we were told that D is in meters, but we're given a depth here of 3.7 kilometers. So we have to change 3.7 kilometers to meters. And if you'll remember, there's 1,000 meters in 1 kilometer. So that means that 3.7 kilometers is actually 3.7 times 1,000, or 3,700 meters. So we're going to calculate the speed at the two different depths, because we want to know how many times faster, which means if we have these depths, we can calculate the speed. So let's start with depth 1, depth of the Juan de Fuca Strait, which is 200 meters. So the speed in the Juan de Fuca Strait is the square root of 9.8 times 200, and then all square rooted. And the result I get is that the speed of the wave would be 44 meters per second. And the speed of the wave in the open ocean, we'll call that D2, for 3,700 meters, the speed there would be square root of 9.8 times 3,700. Again, doing this in my calculator. And actually, I'm going to adjust this 44 meters per second. I should have kept a couple more decimal places, so let me write down a couple of more decimal places in my calculator before moving on. So let's call it 44.27 meters per second. So now we'll go ahead and calculate the speed at the open ocean depth. So when I do that calculation, I get a total of 190.42 meters per second. So if I want to find how many times faster the open ocean speed is than the Juan de Fuca Strait speed, I will divide those two numbers. So times faster would be equal to 190.42 divided by 44.27. So in my calculator, 190.42 divided by 44.27. And I'm going to round this to 4.3. So the tsunami wave is 4.3 times faster. And that's perfectly acceptable for the amount that you have to write for the answer, but you could also write the tsunami wave is 4.3 times faster in the open ocean than in the Juan de Fuca Strait. As a quick note about the speed of the tsunami, 44.27 meters per second is more than 150 kilometers per hour. So one of the reasons why coastal places like the west coast of Canada have to take tsunamis very seriously is because of the speed that these waves can approach at. They go so fast that you need to get warning of them really early so that you can evacuate people to higher elevations.